Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology turned podcast. Everyone, welcome into the program. I hope that you're doing well and you are ready for today's program because we have the one, the only, Mr. Ralph Bond joining us here in just a moment. And yeah, we're going to talk everything. He is, of course, our science and tech trends correspondent. So that can encompass anything from ecology, space, medicine, so on and so forth. Ladies and gentlemen, Ralph definitely finds some of the best stories that we have on the program, and we're very happy to have him on every Friday, and especially this Friday. So, with that being said, we hope that you had a great Thanksgiving. You did something fun. I think something like 3 million people went to the Thanksgiving Day parade this year in New York City. Were lining the streets. 3 million people were lining the streets in New York City. I know that the city's bigger than that, day to day, but just that many people doing one thing, I can't even imagine. So everyone, with that being said, once again, we hope you had a great time. I'm sure that a lot of you are on vacation, and hey, let's keep the good times rolling with Ralph Bond. So everyone, computeramerica.com, that's where we find everything, show notes, super important, past shows, future shows, social media links, all that and more. Ladies and gentlemen, computeramerica.com. Now, let's go ahead and bring Ralph on. He is, of course, our correspondent for science and technology trends, and, of course, he is the tech correspondent for WKEX Portland over at the Mark Mason Show. And, Ralph, welcome back onto the program. How you doing?
I'm doing great, Ben, and again, happy post-Thanksgiving Day. And speaking of the big parade in New York, I was holding my breath the whole time. Terrible sign of the times, thinking, God, please, God, nobody gets shot. No weird, horrible incident. And it was, I guess, flawless. I didn't hear of anything. So thank God for that. I'm thankful for that. Oh, my Lord.
I know that the New York City Police Department gets a lot of flack and stuff like that, but yeah. I will give them credit. New York City Police Department are definitely some of the best at keeping an event safe. They do an amazing job. So
that's great.
Ralph, if you thought it passing by, someone else thought long and hard about it, and they did a great job. So the parade went great. And Ralph, I mean, just on a personal note, how'd your Thanksgiving go? You have a big turkey?
Great.
Was it all good?
It was great. It was the first time my son and daughter-in-law hosted it, and we had a big, huge group of people. It was just so much fun, and we even had a pickleball tournament going on in the driveway.
That is sweeping the nation.
Funny.
Yeah.
Yes. Well, I like the sound of it. I like the sound of the pickleball.
Definitely. And actually one more, because we're heading into the holiday season. Might as well throw out a little factoid and then we'll get on with the stories. But Ralph, do you have the tradition in your family, like a lot of families around the U.S., of putting up the pickle ornament on your tree?
No, I've heard of this, but no, we don't do that yet, I guess.
We always did growing up, and for everyone who is unfamiliar, you put up the pickle, and kids, the first one to spot it, like they're not allowed to touch the tree, and they're only supposed to look around, and you hide it somewhere kind of inconspicuous.
Okay.
And the first one to spot it gets an extra gift on Christmas Day. So stuff like that.
I like it.
Yeah, and the factoid is a lot of people think it's German. Turns out uniquely American. So that is an American tradition that migrated back to Germany. Yeah,
that's great.
Fun little holiday factoid.
I like it.
And of course, like I said to you, I was driving, so I have a lot of Thanksgiving factoids. But we have science factoids, and I think those are more pertinent to what we are doing here today. So, Ralph, why don't you go ahead and tell the nice folks what our mission here is with our segment?
Right. Especially for anyone who's joining us for the first time. This is what we do. So as Ben knows, I'm an aggregator of science and tech news features I find by monitoring a host of online news outlets all day, every day. And I look for important stories that often don't capture mainstream press attention. And sometimes they're kind of weird or quirky stories. And I'm always on the lookout for news that gives us a glimpse into where we're headed in robotics, medical technology, sustainable energy technology, transportation advances, space research, physics, you name it, all across the board. And what I do with each news item in the show notes and on air here with Ben is present the essential points in a really digestible form. So we're condensing these articles just down to the bare highlights. And I stress to the audience that if you want to dig deeper, because there's often so much more information in the individual articles that we'll cite, to check out the show notes that Ben posts on computeramerica.com, because it will give you pictures and links and attributions to who the authors were for the original articles and so forth. I want to stress again, I don't create this content. I capture it and present it in a kind of condensed form. So with that said, I think we're ready to really go through a very diverse package of items today.
Yeah, I think you have an amazing lineup. The first one is, of course, out of this world, but it's an idea that the importance of satellites has really come into focus, and SpaceX and the Starlink program, and the idea of putting up a ton of satellites has really been at the forefront. But of course, that's for Wi-Fi, and I never considered other possibilities. So with that, story number one was very, very new to me.
Yeah, and it wasn't a way for me too. And it's interesting. It's definitely fits in the category of a trend to watch, as it says here, key trend to watch. Space-based solar power is gaining worldwide interest. Great article in Scientific American. And again, get the show notes because it'll give you the link and all that good stuff. So, but this is something that I was not aware of, and maybe you too, Ben. So It's way back in 1968, a U.S. aerospace engineer, Peter Glaser, proposed a bold idea. And in the show notes, we have a photo here of him. He was associated with NASA in a very long and interesting career, and his fields of study were solar energy. That was his bag. So here was the premise he had in 1968. Instead of building gigantic solar farms across vast, ecologically vulnerable tracts of land, Glaser proposed putting photovoltaics technology into orbit on fleets of solar-powered satellites. So they would be solar-powered satellites. That's one part of the equation. It's kind of fun. And then, of course, in space, with no clouds or night to impact light capture, sunlight could be harvested with optimum efficiency and then beamed as microwaves to ground-based rectifying antennas, we'll explain that in a moment, that convert radio frequency energy into electrical energy. So I said, well, wait a minute, I got to know a little bit more about these rectifying antennas. Sounds kind of interesting. And here's a snapshot of what rectifying antennas are. So rectifying antennas, commonly referred to as rectennas, are integral parts of microwave power transmission or wireless power transmission, abbreviated to WPT, systems. And in WPT systems, RF power is transmitted from one location and captured at another location. And the term rectenna consists of parts of words rectifier and antenna, since its function is to absorb incoming radio frequency energy and convert this energy to usable DC power. And I put the source for this little bit of information in the show notes as well. So that's kind of interesting. And it recurs to me, Ben, that I think this was something that the idea of wirelessly transmitting electricity was a big deal to Nikola Tesla, I believe, the scientist from 100 plus years ago. Yeah, it's a very interesting thing. So anyway, 1968. So on Earth, the microwaves again would be converted to electricity and channeled into the power grids across the globe, which was what Peter Glaser's vision was. So here we are, 54 years later. Scientists around the world are now looking seriously at the concept of space-based solar power, with pilot projects emerging in the United States, China, Europe, and Japan. That was the part that I went, wow, okay, this is kind of interesting that this is going on across the globe. And so, for example, bringing it back to our world here, NASA is exploring the current and near future prospects for space-based solar power to see if it could help provide electric power for future moon bases. So NASA's not looking at it so much to provide power for us here on Earth, but for space stations on the moon,
that
and possibly maybe someday in Mars. I think so too. And especially perhaps ultimately someday in Mars. And then, well, but there is a reality check. The article is really great because it kind of looks at the prospects and the realities and so forth. The UK Space Energy Initiative, there's an executive from that outfit that's quoted in the article, and he says 2 technologies need to be investigated and tested to make this a reality. First, autonomous robotic assembly of large solar photovoltaic structures in orbit. And the illustration that's in the article here gives you some idea of these sort of, how would you describe it? Like sails, giant sail-like things. And so you have to figure out a way to first of all, get it up there, get it up in space, in orbit, and then how do you deploy it and assemble it and so forth. So that's the first challenge. The second challenge is beaming power from space to Earth at meaningful power levels. Yeah, your video's good there. Yeah. So again, that's the last part of the equation. Sure, you can do it. Yes, it will work, but will it deliver enough power to make it worth all the effort and time? So we'll see, though, what we've got, again, the United States, Japan, Europe, and so forth. These guys and gals are all out there looking at this and giving it a shot to see if we can pull it off.
We are, and we are one step closer to a Dyson Sphere, which I think anyone who's kind of followed Ray Bradbury and really any science fiction writers, Ralph, like that is like the Dyson Sphere is supposedly the final evolution of a society where you completely encapsulate your star, your sun, in solar panels, and you essentially cube it up in like a Dyson sphere, and you harness 100% of a power that a star is producing. Wow. And some scientists believe that, hey, that's why we're not seeing as many stars as maybe we should be, is because advanced civilizations are out there capturing stars and moving on and taking the energy. This is far from that, and I really appreciate that they were honest with themselves and they said meaningful power levels, because that wireless transfer of energy is ladies and gentlemen, there's a reason why we have power cables running to our house. It's really the only convincing way to transfer electricity, but still I had never considered satellites doing anything other than like communication. The fact that maybe one day they could do power, and I really like the part about the moon base. That makes a lot of sense, because they don't have the. I can imagine trying to assemble solar panels, like let's say on the moon's surface with all that dust and crap. This seems like a much better option if it provides meaningful power. So that was definitely a different one. And honestly, this might be one of the first ones from Scientific American that we've had in quite a while. Good job to them for sure. Story number 1, like you said, eye opener. Story number 2, I think I actually caught this one, and I'm glad that you brought it up in this week, because we did an Intel story last week or the week before, and this one was pretty related. Huge concern about deepfakes. What happens when they're so convincing you can't tell them apart? And that's already a concern for a lot of people. And I'm glad that Intel is looking into this. I'm sure a lot of other people are, but this one's really cool on how they do it.
Yeah, this is really interesting on many, many levels. First and foremost, folks, if you think Intel is just a microprocessor company, think again, their research and development activities and so forth are very, very wide ranging. I know it all too well because way back in 1993, I joined Intel, and my first assignment was to be a media relations person for the Intel Architecture Labs, which was their extreme brainiacs exploration group over here in Hillsboro, Oregon. And so it was such a wonderful time in my life to be associated with all these brilliant people. But anyway, here's the headline. Intel's new deep fake detector can spot a real or fake video. And I got this from ZDNet, and then that led me over to Intel's newsroom itself, which is a wonderful outlet. And here we go. So just in case, make sure everybody understands what we're talking about. A deep fake is a piece of synthetic media that takes an image or a video and uses someone else's face or voice to create a new fake image of people or occurrences. And deep fakes use impressive technology derived from machine learning and artificial intelligence to create extremely accurate impressions of celebrities and politicians and other folks doing and saying things they haven't. So that's, of course, the ethical and moral dilemma that the deepfakes present. To combat deepfakes, Intel recently announced a new technology called Fake Catcher to detect deepfake media, and they found that they are able to do this with about 96% accuracy rate, which is just stunning when you think about it.
Very impressive. And by the way, for everyone out there, I really appreciate the media that you put up there with the Fake Catcher and the little card, and then of course a picture of Donald Musk, which is just what sounds like Donald Trump and Elon Musk mixed together. And while it doesn't, it looks a bit like both. It doesn't look like a fake image. Like that could totally be a person if you didn't know who Elon Musk and Donald Trump were.
Oh yeah, and it also proves the point. Now that one's funny and kind of harmless and silly, but then there's the diabolical ones where people are getting misled. What do you mean Joe Biden said that? Or pick your politician.
And we're moving on to the next one, but I wanted to always bring up this website here. This website is thispersondoesnotexist.com, and it's exactly what you're talking about. If you refresh the page every time, it looks like people's candid photos, that you might find on like Facebook or whatever, their profile picture. These are all AI mashups of multiple people. So this person isn't an actual person. These are multiple people, spooky. Put together, and spooky. Very impressive.
Yeah, it's impressive and spooky all at the same time. Wow. So anyway, Intel's Fake Catcher can detect a deepfake in real time. That's a key, in real time, by evaluating the blood flow in the pixels of a video. There's a lot of science. So it has to be video. Yeah, a lot of information behind that. So you got to dig deeper if you really want to understand this. And in fact, Fake Catcher is the first deep fake detection algorithm that uses heart rates as part of the detection process, not solely, but part of. Wow. And Intel's new technology can identify changes in the color of the veins of a subject when blood circulates through the body. So again, to your point, Ben, they're talking about analyzing videos. And the signals of the blood flow are then collected from the face and translated by algorithms to determine if the video is real or a deep fake. It's just amazing. And again, I stress you really need to dig deeper into this with their information and their video and so forth to get a better understanding of what we're just highlighting here with a stone skipping across the surface of this topic. But it's just, it blows my mind. It's just so fascinating to me that Intel is doing this kind of research. It just, again, shows you the range of what Intel's up to over just about maybe 2 miles from where I'm sitting right now is where the Intel Architecture Labs is headquartered. So, wow.
Yeah, for sure. And of course, we played a bit of the video there, and it's very cool, the kind of the way that they do it. I read some comments on this article, the last time I read it. And the comments were saying like, okay, now deepfake is just going to fake it's just going to fake one more thing. It's going to learn to fake the vein coloration that they're talking about. That seems a lot harder than I think they would say, because in the video they kind of show the kind of the diagram of people's veins and the color and things changing like right here, and you can see here in like the bottom right, the signals are all over just all over the spectrum. I think this is a very, very good method that Intel has come up with, obviously, but it also, the fact that it works with real-time video is even better. It's
bizarre, isn't it?
Yeah, it's super impressive. So, amazing story, and people always talk to me about deepfakes. They're scared of them, Ralph, like you were kind of bringing up early on, and people were always afraid. And I'm like, deepfakes are a problem right now, and they will, likely always be a problem because humans are, kind of gullible. But technology, I think, is going to do our job for us, and it's going to automatically put like a little label, a little sticker on any deepfake video and say, this video has been edited in some way. Be careful. That's what they're going for, Intel and everyone else. So fingers crossed that they actually catch up before real damage is done. That's story number 2, and Donald Musk just cracks me up.
I know,
story number 2. Story number 3. This one piggybacks, I guess not really continues, but we've heard of efforts like this before, but this one is from a source that, we have not heard of before. Well, Honda, of course, the car manufacturer, we have heard about them, but the technology is getting traction, and that's important.
Yes, 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 you're so right. The headline here is researchers at Honda. And again, like Ben said, we think of Honda as the motorcycle and the car company and all that good stuff, are working with microscopic algae that captures CO2 and convert it into fuel and other useful products. And so this caught my eye right away for a couple of reasons. One, Ben, over the last several months, algae and mushrooms and all kinds of things that you don't think of as having high-tech potential are being explored. We talked about mushrooms being transformed into artificial leather. Building materials, yes. Artificial leather, remember that one for the car makers and that sort of thing. And algae seems to be another thing that's popping up more and more and more in our discussions and our forward-looking research stuff. So that's why I said, a car company doing this kind of research, that's interesting. It shows you, like Intel, if you think of Honda as just a transportation company, think again, because their research and development is looking at some pretty wide-ranging stuff. So with all that said, by the way, I got this story from Newsweek, and there's a really great image in the article here. But here we go. So at Honda's Research and Development Center north of Tokyo, you'll find several long, thin tanks filled with a green goo positioned on top of one of its buildings. The tanks, to me, they look like arrays of tilted and vertical solar panels. That's kind of what they look like on a flat rooftop, but they're a test bed for a genetically engineered microscopic algae. And the tanks are being fed carbon dioxide captured from the air through a bubbling tube as algae absorb the sunlight and produce oxygen. So they're actually producing oxygen as well. So Honda's goal with this microscopic algae research is to achieve a win-win scenario of permanently, that's the key, permanently capturing CO2 from the air and producing ingredients to make useful bioproducts and fuel. And why do I stress permanently capturing? There's a lot of technology out there that's being explored where you capture CO2 from the air, maybe you put it in the ground. And you could argue that's not permanently getting rid of it, right?
We did one of the stories that the company was going to convert essentially tractor trailers into giant air filters, and they were going to put them out in the middle of like North Dakota or something like that. And then, Ralph, like you said, they were going to bury the CO2 that they pulled out of the air. So,
So that's why this permanently really caught my attention. I thought that's significant. So going on here, it says, and this research, by the way, it's kind of fun. It has an international twist. Honda purchased the strain of microscopic algae being tested called Driamo from the University of Texas. So it brings it back to the United States. Isn't that fun? And now, by adjusting the amount of phosphorus and nitrogen in the culture medium in which the algae grow, Honda can cause the Driamo algae to make more protein, turning the dried and spun in a centrifuge product into food, supplements, and cosmetic products. Okay, that's kind of cool. So that's the protein part of the equation here. And then using another adjustment, microscopic Driamo algae can output mostly carbohydrates, which can then be transformed into glucose. Ding, ding, ding. The glucose can then be used to make ethanol, good old ethanol, which can be made into a fuel or a bioplastic resin. So that's your win-win scenario, permanently capturing CO2 and making food and other useful products and even possibly fuel. So, wow. And this part, Ben, is really great. The process is carbon negative, with 1 gram of self-replicating Driamo microscopic algae absorbing 2 grams of CO2. Wow, it's just a win-win-win-win-win.
And really, it's not even just like negative. It's just straight up 1 to 2, 100%, I guess, kind of, or 50%, whatever you want to call it. Like Ralph, it's not like 99 grams turns, 100 grams of algae, reduces by 101. This is like 1 to 2. That is amazing.
Isn't that something?
Of course, at scale. Ralph, I actually looked up Driamo algae. And for everyone out there, it's kind of spelt like Dream O, but led me to this website, Algae Planet. And who knew, Ralph? There's a whole website.
Algae Planet.
Algae Europe 2022 is going to happen in December.
I love
Ralph,
it.
people are really getting into algae. It seems to be.
Isn't it great? I mean, the world might be saved by the smallest and the most humble little ingredients like algae, right? And seaweed and other stuff like that.
Wasn't
Gotta love it.
and really wasn't it that way in like War of the Worlds? It was like, you know, the humble common cold killed the aliens. Like, you know, hey, fingers crossed.
Something like that. There you
Something
go.
so simple, but that's really cool. And the fact that Honda is, of course, spearheading this is, you know, just kind of
Fascinating.
it goes to show the viability that big companies are starting to, you know, test it on their own. So. Story number 3,
yeah.
Story number 4. This one is also really cool because
Yes.
you know, we've had a lot of talk back to Elon. He has his whole Neuralink brain interface, and ever since then, I guess the mainstream has really come to the idea that being able to control computers with your brain, super important. Not just, you know, not just for everyday people, but especially for those with disabilities, those who can't, who don't have motor function. There's a lot of use cases for not having to control something with your hands. Story number 4 takes it you know, kind of takes it to the next level because, Ralph, you only need to be breathing, and that's pretty good.
Oh, yeah. Yeah. And this is great. I got this from futurism.com, and the headline here is Scientists create a brain stimulator implant powered completely by a user's breathing. So that's why it immediately caught my attention. And the image there that's in the article that you're showing is a little misleading. You need to use the image that comes from the University of Connecticut, but I'm jumping ahead of myself.
Right.
So battery-powered brain stimulators can be a life-changing treatment for those suffering from neurological disorders like Parkinson's disease. So that's the problem or the purpose or goal or motivation behind all of this. These little brain stimulators are normally placed under the skin in the chest area, and their electrodes are implanted within the brain. So as I understand it, it's this kind of pulsing of electric charge into a certain part of the brain that helps Parkinson's disease people, you know, thwart their disabilities, right? I mean, so it's that kind of a thing is what's going on. And the article gets into more detail on that. But here's the problem, guys. Today's brain stimulators require surgery to get their batteries swapped out every 2 to 3 years, which is both costly and physically taxing. So recently, researchers at the University of Connecticut, and their article on their website really does a great job on this, announced they've developed a way to charge brain stimulators for this purpose solely by harnessing the energy generated by breathing motions in the patient's chest. Wow. And it makes use of good old triboelectric charging, in which static electricity is generated through friction. And if you're looking for an example of that, think of the time when maybe you've shuffled across a carpet and you've touched a friend or touched something and you produce a little static electric shock, right? So that's what we're talking about with triboelectric charging. And the researchers made use of this effect, triboelectric charging, by applying a triboelectric nano generator near the chest wall. So as a result, inhaling and exhaling causes the chest wall to rub against the generator, creating a current that charges a supercapacitor, which in turn powers the brain stimulator. No more having to go every couple of years to open the patient up and swap out this device for a battery fresh version. How wonderful is that? I mean, it's basically makes it a permanent solution for all intents and purposes.
Yeah, you know, short of components, you know, kind of breaking down in the human body, and you know, just being able to power just like that without a battery pack or anything else.
Right.
Very, very important. And I've seen other solutions to this, Ralph, that included like, you know, kind of the wireless charging that you may use for the cell phone nowadays, the magnetic induction.
Yeah, right. Right.
You know, some people have said that, you know, you could recharge a battery using that. This, because of the passiveness of it, you know, it just does it. Very, very important. And of course, the diagram that I've been showing on the video portion shows, you know, kind of the pig, and you know, they're of course doing this with pigs first, and then they're going to move on to humans. But to, you know, kind of have it all self-contained, and like you said, just breathing. That is, I'm wondering how much electricity, and if this can help other implant type medicine, because this seems like really a game changer.
Exactly. Your point's really well made. What other purposes other than helping Parkinson's disease folks, where else could this be good for stimulating electrical power? And it's probably because you're breathing all the time, hopefully. It's going to be constantly charging the battery, right? So, I mean, I don't know. I think that's fascinating. I love that one. That one I thought was so important. And again, it's a good example of how Ben and I try to leave you with uplifting, inspiring stuff.
Absolutely. And I think you do a fantastic job of that. And ladies and gentlemen, I'm sure that you've already been having a great holiday weekend, but yeah, we hope that you have an even better one now. Ladies and gentlemen, links, pictures, videos, images of everything we just talked about will be up on the website. And of course, also over at Ralph Bond Wicks. Just type that into Google. You come up to this page here over at Computer America, and all of his segments are right there in one easy to find spot. So Ralph, thank you so much for coming on, and thank you for your time. Everyone else, thank you for your time, and we hope that you have a great one. We'll catch you here in, December. Everyone, where does the time go? Catch you next time. Bye-bye.